Hello everyone, I'm Nick from Tirapid, and today I want to talk about crucial yet often overlooked step in CNC machining, roughing. In my over a decade of experience, roughing is like laying the foundation when building a house. It might not be the highlight of the final product, but it is determined whether the entire machining process is stable and efficient. Roughing involves taking a large raw billet and using large tools to quickly remove the bulk of the excess material, shaping the initial outline of the part and setting the stage for the subsequent finishing work. I typically opt for large diameter tools like milling cutters ranging from 20 to 50 millimeters. I set the feed rate between 1500 and 3000 millimeter per minute with a cutting depth of 5 to 15 millimeter, achieving and material remove rate MRR of over 300 cubic centimeter per minute. For instance, in an aerospace project, we rough machined an aluminum alloy structural component measuring 435 times 185 times 50 millimeter, keeping the time per piece under 2 hours and improving efficiency by nearly 40%. However, roughing is not about cutting recklessly. It requires strategy. The type of material greatly influences the cutting parameters. For example, with LM6061, we can utilize high speeds, like 12,000 RPM, and the rapid feed rates. But for 304 stainless steel, we need to reduce the feed to 1,000 millimeter per minute, while using high-pressure coolant to control tool wear. Another point that is often overlooked is tool selection. Roughing stages need to withstand significant impact force. So I go for tools like serrated milling cutters or carbide tools that are wear resistant and highly durable, particularly suitable for heavy cutting. Cooling stages during roughing are also crucial. We have used a 70-bar high-pressure cooling system that extended tool life by 25% and prevented workpiece deformation. Some might wonder, why bother with roughing if it is so porous? The truth is, without efficient and stable roughing, you can't even begin fine machining. A failed roughing attempt wastes not just materials, but also valuable machine time. A final tip: always ensure the workpiece is securely clamped during roughing, especially with deep cuts and high fits. Any slight looseness can lead to tool breakage or scrap, affecting the entire batch's yield rate. That's all for today's insights on CNC roughing. If you'd like to share more CNC machining experience with me, don't forget to reach out and follow my channel for more updates. See you next time.